All right, we are going to learn the final method for solving systems of equations, and it is called the elimination method. This is going to be called level 1 because it's going to be a little bit more basic than level 2. All right, so let's talk about generally how to solve a system of equation by using the elimination method. So the way that you eliminate is you solve the systems by either adding or subtracting the two equations, and the goal is to eliminate a variable. And I'm going to show you what this is in a moment. So this first step is to make sure that the equations are lined up. So what that means is your y variables are lined up, your x variables are lined up, and your constant variables are lined up. Constants, not variables. Constants are lined up. Okay. So then once you do that, you either add or subtract the equations, and the goal is to eliminate. All right. And the goal is to eliminate the variable with the common coefficients. So notice how these coefficients of y are 1, and these coefficients of x are 3 and 1. So the common coefficient, this common coefficient, is right here. These are in common. They have the same coefficient. Okay. So in a moment, I'll go over this. Then after you add or subtract the two equations, you solve for the remaining variable. And then you substitute your answer into either the original equation, and then you solve for the other variable. So I'm going to show you what this looks like. So here's our common variable. They're both 1. If the coefficients are in common and have the same sign, you would subtract the two equations. If your coefficients have the opposite signs, then you would add the two equations. So these have the same signs. These are both positive 1. So I would subtract these two equations. But you know how much I hate subtraction. So this is how it works. You're going to add the opposite, opposite, opposite. So you change everything else to the opposite. So you change the subtraction to addition and make every other term the opposite. The reason why I like this is because it eliminates errors. Adding is so much better than subtracting. All right, so now it's time to add our two equations. Your goal is to always add. Subtraction stinks. So 1y plus negative 1y is 0. Bring down your equals. 3x plus negative 1x is 2x. 4 plus 2 is 6. And then you just solve. Minus 6, minus 6. So 2x equals negative 6. Divide by 2, divide by 2. X is equal to negative 3. All right, so we solved for that remaining variable. Now it's time to substitute negative 3 into one of these two equations. Let's plug it into this one because I don't think I'll have to do as much math. So y would be equal to negative 5. Okay, so negative 3, negative 5 is your point of intersection if I were to graph this thing. Let's see if I get negative 5 here if I plug in negative 3 into the other equation. So 3 times negative 3 plus 4. Yes, I get negative 5. So since this point makes both equations true, it is the solution. All right, let's look. Are my variables lined up? They sure are. Okay. X variables, Y variables, constants, all lined up. Typically with systems using elimination, your both equations are going to be in standard form. They're typically, you don't solve a system when they're both in slope-intercept form. It's always usually when they're in standard form. Okay, so now this coefficient is 1. Let's dress it naked. This coefficient is 1. So now I have coefficients with the same sign. I would subtract. But you know me, I hate subtraction. So add the opposite, opposite, opposite. So notice I just changed all of these to the opposite signs. So now, since these have opposite signs, I can add the two equations. So 1x plus negative 1x, those eliminate. That was my goal. 4y plus positive 1y, dress this naked y with a 1. So we get 5y. 13 plus negative 3, 10. Divide by 5, divide by 5, y is equal to 2. Okay? So if y is equal to 2, let's plug it in for a y. I could plug it in for that y or that y. Which one will give me the least amount of math? Let me put it here. I don't think it's the least amount of math, but we'll see. So x plus 4 times 2 equals 13. X plus 8 equals 13. Subtract 8, subtract 8. 5. X equals 5. All right. So is 5 plus 8 equal to 13? Yes. Is 5 plus, oh yeah, that was minus, wasn't it before? 5 minus 2, I forget what this was before. I shouldn't have done that, but it should make both the equations true. So 5, 2. All right, next one. Let me rewrite this so I don't come in and make that same mistake twice. Okay. Common variable right here. But this has the same sign, so I would subtract. I hate subtraction. So let's add the opposite, opposite, opposite. Now, my goal is always to add. 3x plus negative 3x cancels out. Negative 10 plus positive 9 is negative 1y. 14 plus negative 15 is negative 1. Divide by negative 1, divide by negative 1, and I get y equals positive 1. Great, that's part of my puzzle. Let's plug it in for one of my variables. How about this one right here? So it's a positive 1. So 3x minus 9 times 1 equals 15. I'm going to add 9 to both sides, because 3x minus 9 equals 15. So you add 9. So 3x equals 24. Divide by 3. X equals 8. Let's see if it works. 3 times 8 is 24. 24 minus 9 is 15. 3 times 8 is 24. 24 minus, this would be 10, is 14. So it works for both of them. 8. So this is my final answer. Okay. So sometimes your x's are not going to be the same. Sometimes your y's are going to be the same. So let me rewrite this again, because I don't want to make that mistake. Okay, so my y's are in common, but look, they're both the same sign, so I would subtract the two equations because they are both positive 2. I hate subtraction, so I'm going to add the opposite, opposite, opposite. Okay, so now I can add the two equations because I have my positive 2 and my negative 2 y's. So these eliminate. That was my goal. 4x plus 2x is 6x. 6 plus negative 18 is negative 12. So x is equal to negative 2. Okay. So if x equals negative 2, I need to plug it in for an x. Which one am I going to do the least amount of work? I'm going to plug it in here because I know a negative times a negative is positive. I don't like dealing with negative numbers. All right, so I get 4 plus 2y equals 18. Subtract 4, subtract 4. So now I get 2y is equal to 14. Divide by 2, divide by 2, y equals 7. So my x-coordinate is -2, my y-coordinate is 7. And then let's test it. So 4 times -2 is -8. -8 plus 14, because 2 times 7 is 14, equals 6. Yes. -2 times -2 is +4. +4 plus 14 would be 18. So yes, that is correct. Okay. So I have set you up here so that the common variable is already the opposite. So if it's already the opposite, what you guys need to do with these is add the two equations. Same with this. Already the opposite. So you're going to do 5. So because they're the opposite, and this is your common variable, you're going to add the two equations. So do 6. Again, this is my common variable. Because these are the opposite already, I'm going to add the two equations. Okay? So can you please, for me, do 5, 6, and 7? Okay, this eliminates. You get 16y equals 16. Y is equal to 1. Let's plug in 1 right here. 4x plus 9 times 1 equals 5. I'm going to subtract 9 from both sides, so I get -4. And divide by 4 on both sides, so x is equal to -1. So your point of intersection would be -1, 1. This one, you add, so these eliminate. 10 plus -2 is 8x equals 24. Divide 8 on both sides, so x equals 3. Where do I want to put this? How about I put it here? So -2 times 3 plus 3y equals 6. So this becomes -6 plus 3y equals 6. I'm going to add 6 to both sides. So 3y equals 12. I'm going to divide 3 on both sides. So y is equal to 4. So the point of intersection here is 3, 4. 7. I can add these. These eliminate. 1x plus 3x is 4x equals 28. Divide by 4, x is equal to 7. I'm going to plug it here. So 7 minus y equals 10. Subtract 7, subtract 7. -1y, remember this naked 1, y has a 1, equals 3. Divide by -1, divide by -1, y equals -3. So the point of intersection here would be 7, -3. Don't forget my parentheses. Okay. So what do you do if your variables are not already lined up? So notice there's an equal sign here and there's an equal sign over here. So I have two choices. I could subtract the 3y from both sides. So I could say x minus 3y equals 11. And then this just stays the same. Or I can add 3y to both sides. So then the top equation would stay the same. And then I would add 3y to put it over here. Plus 16. Either way, you're going to come up with the same answer. So I'm going to use, I'm going to go with this one here. All right, so this is what's in common. My y's are in common, but they're the same sign. They're both negative. So I would subtract the two equations. But I hate subtraction. So I'm going to add the opposite, opposite, opposite. Now add them. Address this naked x with a 1. 1x minus 2x is negative 1x. These eliminate. 11 plus negative 16 is negative 5. Divide by negative 1, divide by negative 1. X is equal to positive 5. All right. Where do I want to put this? I'm going to put this positive 5 right here. So 2 times 5 minus 3y equals 16. So 10 minus 10 minus 10. So I get negative 3y equals 6. Divide by negative 3, divide by negative 3. Y equals negative 2. So the point of intersection here is 5, negative 2. Okay? Can you please do number 9 for me? All right, so for number 9, you should have gotten 4, 0. I'll look and see how you did on the data and see if I have to go over this. Number 10. So I've got the same variables all over the place, right? Common variable, not common constant. So I would subtract the two equations because these have the same sign and these also have the same sign. But subtraction stinks, so add the opposite, opposite, opposite. What do you get? And tell me what's going on. So do number 10 for me. 11, we have to line up. We have to line everything up. So I'm going to subtract 2x from both sides. So I get y equals negative 2x minus 10. And down here, I've got negative y equals positive 2x plus 10. So what's happening here? So if you guys could please do 10 and 11 for me, and we'll come back in a moment and talk about it. All right, 10, you should have gotten no solutions because these cancel out, these cancel out. So I get 0 over here. And then negative 10 plus 3 is 3. These don't equal each other. So this is an example of no solutions. No solution. But over here, these cancel out, 0. These cancel out, 0. These cancel out, 0. So 0 does equal 0. Everything is canceled out. This is the same line. So this is this is no solutions. Oh, no solutions. This is infinite solutions. Ignore that. Not an infinite sign. Or infinite solutions. Okay? So that is it for elimination. Tomorrow we'll do some more and master this. My opinion is this is easier than substitution for me, but it might be a little bit different for you. Okay, thank you.